Hi, Joyce.
Hi, Joyce.
Pause and work out these in the back of your spiral, and then we'll check them in just a second. Okay. Number 1, Gerardo, what'd you get?
D.
You guys agree? Nice. F of B minus F of A all over B minus A, so F of 3 minus F of 0 all over 3 minus 0 simplifies to B, 1/3. Number 2, Amanda Johnson, what'd you get?
E.
How come?
Because F is not continuous at x equals 4. The limit is not equal to the.
What'd you get as the limit as x approaches 4?
3. No, 4. Sorry, 4.
Coming from the
3.
left, no. Coming from the left
Oh,
is 3.
different?
Coming from the right is 3.
Yeah.
But F of C is not equal to 3.
Yeah.
Okay,
George
there you go. So then plugging in, we got 3 from the left and what was from the right?
3.
And then 3 from the right.
Oh, so they just make it the entire thing?
Yeah.
Okay. Because they agree. So does the limit exist?
Yes.
Yes.
Continuous.
But do they agree? Nice. So then it is not continuous because the limit is not equal the function value. Number 3, Amanda Devisarian. What'd you get?
I got E.
You guys agree?
Yes.
Yeah.
I got
How'd
E.
you find it?
Oh, I plugged in 2 to get into n
Oh,
of x to
never mind.
get the y,
Uh-huh.
and then I found f prime of 2 so I can get this slope, and I plugged in into the point slope formula.
Nice. And then simplified to get slope-intercept. Jordan, you good?
Yeah, I wrote E. I mean, I wrote negative 4s plus 13, but I put E for
Oh,
some reason.
yeah. So easy. So easy to do. 4A. George, what'd you get?
Negative 3.
You guys agree?
Yes.
George, keep going. B.
I got h squared plus 8h plus 3.
H squared what?
Plus 8h plus 3.
I disagree.
Yeah.
I got negative h squared minus 4h minus 3.
I see negative h squared plus 6 plus 9 plus 15. No. 6 minus 9.
Negative 3.
Negative 3. And then 2h and 6h. That's what I got.
No, because
That's what I had before.
you get h squared plus 6h plus 9, but then the negative distributes, so it's negative.
You get negative 9
Yeah.
plus 6h
So then
plus h.
2h, 2h minus 6h. Thank you. Negative 4h, right?
Mm-hmm.
Because it'd be 6 plus 2h minus h squared minus 9 minus 6h. So 6 minus 9 is negative 3. 2h minus 6h is negative 4h. And then h squared is just a negative. Does that sound better? By foiling. And then C. Jackie, what'd you get?
Again, negative 4 minus h.
So then you have all of that minus f of 3, which we got to be minus negative 3, so plus 3. So the 3's cancel, pull out an h, reduce. Yeah, negative 4 minus h or negative h minus 4. And then letter D, technically all you have to do is the limit as h approaches 0 of what we already have, which should end up being negative 4. Did anybody power rule it and make sure we were good?
Yes.
So then power rule this should match up with f prime of
X.
at
3.
when x is 3. So that would be 2 minus 2 times, plug it in, because my derivative is 2 minus 2x. So 2 minus 6. Check. We good?
No.
Yeah.
On the AP,
Uh-huh.
if they ask us to for something like C, will we have to do it like that?
Multiple choice.
Well, C, it doesn't have a limit as h approaches 0, so C, this answer does not match up with the derivative, so I'm not really sure you can do it any other way. Does that make sense?
Yep.
But
It helps
D,
with A and
definitely.
B gives us basically the answer for C.
Does really?
And
Oh, I
it's
guess you could factor
It
the
asks,
top.
it
Yeah,
asks
your
you what f
differences.
of
3 of those H's, and then so take B minus A and then divide by
Yeah.
So it just because of the way it was asked, there was kind of only one way to do it. Tricky. What? The test? Hold on. Let's go ahead and check answers for the evens for section 2.4. So in the front of your spiral, homework number, what was that? 7? 6? I put 7, I was wrong. That's right. Homework number 6. I think we started off the first even was number 6, right?
Yeah.
Yes.
Yeah, please.
Let's do the evens first, then we'll go back to odds. So 6A would be negative 2 over pi.
Negative.
B would be 0. Does the negative make sense?
Oh yeah. It does. I just don't know how to count.
That happens. What's our next or even?
10.
10. Ready? Final answer, negative 2 for A. B, y equals negative 2x minus 1. For the tangent line, normal line opposite reciprocal. So the slope needs to be positive 1/2, plugging in the same point, 1/2 x minus 7 halves. Yeah.
Why does it have to be 7 halves? Why can't it just be? Or where do they get the 7 halves?
Oh, they just got 7 halves by simplifying. Technically, to get to the man, we could have just stopped there. We would have had negative 1/2 minus 3 over 1. You have to make 3 into 6 halves. So then we'd have negative 1/2 minus 6 halves, negative 7.
Why can't we just flip the,
Yeah.
the slope?
Like, yeah.
We flip the slope,
Why can't we just like
negative
do
2 over 1. But the problem is a perpendicular line is not going to have the same intersect. So we have to go find a new intersect. Does that make sense? Yeah. So the slope changes, but since the slope changes, then it distributing in to the point is going to change the value. Maybe just think about it. It's like, oh yeah, they're going to hit at 2 different spots. So, yeah. And the letter D was like, what? Graph it.
Yeah.
So we can see at a point, we can see the tangent line, then you should be able to see the secant line hitting it. Cool. Number next one.
30.
Well, that was close. Look at that. Did you guys like number 30? I did.
Yeah, that was easy.
It was a related rates problem, kind of.
That's what I thought.
Mm-hmm.
But like,
It was like intro because it was just taking the derivative.
yeah, I was
Yeah.
like, this is a related rates problem. But I don't ask. Really.
At first, I was just like, wait, what? And then I looked it up on Yahoo Answers.
You
and
had
it's
to
like,
get the formula, yeah. So as soon as it said
Yeah.
volume of a sphere, 4/3 pi r cubed.
Yeah.
And then when it says the rate of change with respect to the radius, it's just take the derivative.
Yeah. I didn't realize that like I was like, wait, what? Radius is fixed.
But then if you think about a balloon,
It's still an ellipse.
Well.
But I get the point.
the idea is there. So at the end of the day, when you guys solve, whether you use the limit definition or whether you use derivatives, either way, you get 16 pi.
I got 36 pi.
Oh,
You plugged in the wrong one. I did the same thing. You plugged in.
what did you plug in?
I plug in R equals 3 inches.
It's 2.
It's 2. Oh, number
I did the same
29 says
exact
3, number 30 says 2.
Seriously?
I
Yeah.
did the exact
Son of
same
a goat.
thing.
That is so funny. I mean, they do look super similar. So there you go.
And I knew that was happening because when I was copying down the problem, I was like, look at the wrong one.
And I just, didn't get it. Why do they say changing at a rate of inches cubed per inch?
Because it's 16 pi as in volume for every radius.
Yeah, dv over dr. Good. So it'd be inches cubed over inches. Or
You
cubic
should say
inches per.
inches squared. Or, oh, no, you can't. Never mind. Never
No,
mind.
I think it doesn't have it. Yeah, it doesn't have the same. Do we have any more evens?
42.
Or the last one? Oh, and 44.
And then 50 and 52.
And I didn't get 49 through the last one.
42 is false.
42.
Wow.
Okay.
Because there's a sharp point.
There's a sharp point. So, the slope of the tangent line coming from the left is -1, coming from the right is +1. Will the limit exist if there are two different slopes? Nope. The limits do not agree.
Well, I had actually a question.
On this one.
It might have actually been on something from yesterday. One. was like
You guys are
Fine.
checking 44 already, right?
find the limit from like two different points, and it was like a piecewise function, and it was like from two different parts of it, and like if you take the derivative of both, they don't agree. But it said, oh, we take the one-sided difference quotient limit, then they're false. Then I was just like, do I have to do the
I think that's the one, George, that's the one that you were doing, right? Where you had to take the derivative of a piecewise and then it wasn't, like it was continuous, but it wasn't differentiable?
yeah
15.
15 or 50?
15.
Oh, that's the one.
Is that the one?
Like, do you just know that if you take the derivative of both and that's the same thing, then it's not
Yeah.
differentiable.
Yeah, that'll be the short one. And then number 50, we had that one too, right?
Number 50 and 52. Yeah. Did you put infinity?
I didn't get.
Yeah, I
49
didn't
to-
even know
what
how
to
to
do.
do these ones.
49.
49 to 52.
Totally
You
lost.
just gotta use a graph and then
You say who to what now?
you gotta use a graph. It says to use a graph.
Okay. Yeah, the nice thing is it does let you graph it. That-
That would make a difference.
That makes life a little bit easier.
Huh?
But then when we're considering, uh-oh.
You got the right.
I'm not
It's
one.
a short point.
M.
Yeah, I have a short at x equals 0.
That you should just know.
If there's a sharp point, there can be a vertical tangent line.
Because
Thank
the
you.
limits are.
But wait, how could we consider the limit as h approaches 0 of x to the 2/5?
You can consider it 5 or square root of square fifth root of x squared.
Does that make sense? Not h, sorry, I should do x.
It should just be 0.
Because the actual question is what's going on at the tangent line, right?
The actual question is, the curve y equals f of x has a vertical tangent line at x equals a if the limit as h approaches 0 of the difference that equals infinity or negative infinity. Use the graphs to find the vertical tangent line at x equals.
Oh, the graphs of the derivative, not the graphs of the original. I think that's what's going on. Because the original is just going to be, the original is going to be continuous, right? Because it's fine.
But there's still going to be a vertical tangent line.
Yeah,
I found two. On number 50 and 52, there was vertical.
How do you
Number
know?
50 and 51, there were vertical tangent lines.
Oh, how do you know this is a vertical tangent line? Like, is there like a test for that?
There's a line that's going up.
You take the derivative?
It's a vertical asymptote, basically.
You can graph.
Like, if the derivative has a vertical asymptote? Oh.
Right?
Yeah.
To be subtracted, it'd be negative 3/5. So then if we plug in 0, it'd be 2 over 0,
Yeah.
which would be infinite slope. Right? So an infinite slope, technically if you come from below and come from above, coming from below it's going to be negative, coming from above it's going to be positive. Meaning below 0 and above 0. So then technically that's what they were doing when they graphed the derivative, when they graphed this function, that's what's going on. So they're saying like, hey, this is the graph of the derivative and those limits don't agree, so therefore the limit does not exist, hence the curve does not have a vertical tangent. It does have infinite slope, but it's disagreeing infinite slope, so we would say D and E. Because the derivative is defined to be a limit of the slopes of the secant lines, when we plug in 0, we see the derivative shows or indicates an infinite slope. But the problem is when we go to the actual function itself and look coming from below and coming from above, they're going to different infinities. And since the two limits to get our derivative, to get our slope of our tangent line, since they don't agree, then the slope does not exist, which means it's not a vertical tangent.
How would it be a vertical tangent?
If they agree, like in number 50. So number 50, as you come from below and come from above, they're both positive infinity, so we can say it is a vertical tangent line with a positive infinity slope. Does that make sense? So the derivative is going to not exist. It's still, the derivative does not exist, but we can say that there's an infinite slope, so we can say there is a vertical tangent line.
So it'd be like a square root function?
That would be an example, like a square root function. As you come in, it'd be approaching an infinite slope at 0. But a better way of thinking about it is like tangent inverse of x at 0, or the cube root of x at 0. That's true. If that makes sense. And then 51, 52 are kind of the same idea, right?
Yeah, they were both.
And that 51, whoops, sorry, he's up here. 51 agreeing, so we can say yes, there's going to be a vertical tangent, but then 52 disagreeing, so we can say no vertical tangent because they don't agree.
Because there was a sharp point on 49 and 52. So since the derivatives don't exist, they can't agree, right?
Say it one more time.
Um,
Technically, the derivatives don't exist for any of these.
okay.
But we can say that how they don't exist for 50 and 51, they don't exist at vertical tangents, and for 49 and 52, they don't agree. So it's not a vertical tangent. Now, if we were to graph, what does x to the 2/5 actually look like?
X to the 2/5, it's a sharp point at 0.
Perfect. And x to the 2/3 should also have a sharp point at 0, right?
X to, yeah.
And remember, sharp points, even though both the slopes are going to infinity, at different infinities, they do not agree. The limit does not exist, so the derivative does not exist. Which is a little confusing because it's like, wait, there's a vertical tangent line, but the sharp point kind of trumps the vertical tangent lines. Ha 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 ha. I didn't get why you were laughing, and then I did. X to the 2/5. Oh no, wrong one. Oh no, wrong view. There we go. So that one's going to negative infinity, this one's going to positive infinity. Since they do not agree, sharp point, the limit does not exist. The derivative does not exist. Cool. Is that our last even?
Hopefully.
I think so. Okay, you guys said you had some questions on odds. Let's check it out. What questions on odds do you have?
15. Oh wait, you already answered that one.
I already answered
So you
15.
can just
Jackie was
find the derivative of it.
37.
Say what again?
Find the
Oh,
derivative.
Oh yeah, that makes your life easier.
Yeah. Any other questions besides 37?
37 is the sensitivity.
Just a sharp point means that as the limits converge to 0, the limits converge to a point, the limits don't agree.
The limits don't agree.
So
So you know what's on the graph based off the limits don't agree, there's going to be a sharp point, and then if the limits do agree, going to infinity or negative infinity, there'll be a vertical tangent line instead.
the sharp point thing wouldn't that just be like a zero slope?
No. A zero slope is only if you have a smooth curve,
Okay.
like a maximum or minimum. Alright, number 37, I think I have the book open, sorry, that's why I was pausing. But let's go back to here. Back. Patient's temperature, T is the function of the dosage of medicine is given by 9 plus 4 over 1 plus G. So that's a function of temperature. Find and interpret the sensitivity of the patient's temperature to the dosage when D is equal to 2 milligrams. Okay, remember, sensitivity, who is that?
Sensitivity is the
Change in T over change in D.
Yeah, D's on the bottom, thank you. And technically, if we're thinking limit at one dosage, right? It's not between two separate ones. At one dosage, that would be like a tangent or like a derivative. And interpret the sensitivity of a patient's temperature to the dosage one. So if I want to go ahead and at one time, I need to think about delta D going to 0. I have my function T of D. So if we were to just take it with the derivative, what would we get?
I don't know why they take it.
Oh, you'd actually get rid of something.
Which made it so much harder.
Yeah, you do. It's very complicated.
Well, we could do it limits too, because remember we could go ahead and do T
Oh,
of
you get negative 4.
D minus 2 minus
T of 2.
T of 2 all over D minus 2, and then the limit as D approaches 2. That would have been the longer way of doing it, right?
You would just get negative 4 over 1 plus 2D plus D squared.
Oh, you don't even need T minus. Sorry, you don't need D minus
It's
2.
T of D.
Just T of D. Yeah.
I don't like that version. Very good.
There we go.
It took me forever.
It's okay, George.
Well, you just have to do your
Oh my god, did I do it wrong? Miss C, I think I did it
It's
wrong.
not negative 4/9, you're fine.
Oh, I gotta. That's weird. What? Miss D? Wait, no. Oh, I see. Never mind. I thought I did chain rule wrong, but it's just the derivative of D plus 1 is just 1.
And it was 99 plus 4 over 1 plus D.
Yes.
Minus, and plugging in 2, that'd be 3 4/3. So we just say 99.
So then you're gonna subtract the 99s.
So the 99s cancel. I have to get rid of my common fractions. You guys remember, just for simplifying complex fractions.
Multiply by 1 plus B.
Why am I doing the 3 2?
Get rid of the.
To get rid of the 4/3.
Should have done that one too.
Would make it a little bit easier.
Oh, a lot more easier.
Then when I would have distributed in, I would have gotten 12 minus, distribute in, the 3's cancel. 4 plus 4D. And then I would have had 3D minus 2 times 1 plus D. At which point 12 minus 4 is going to be 8. 8 minus 4D, yeah, exactly. Then pull out the 4. I'm going to pull out a negative 4, right? So then I get a positive D minus 2, which is going to go ahead and cancel out with what we have down below. And then plugging in the 2, that'd be 3, 3, and 3 is 9, and then we get negative 4/9.
Yes. Degrees Fahrenheit per.
So the temperature should go down about 4 degrees per 9 milligrams, if you want to think of it that way. Or it go down negative 4/9 of a degree per 1 milligram.
At that point.
For the dosage that's been currently given to them, which is 2 milligrams. Does that make sense? I don't know. I thought this was stupid. Maybe not fun. It's just interesting. But then you could have taken it. All right. Any more questions? I accidentally paused the recording. All right. Any more questions? Are we good?
Okay.
Sweet. You guys ready? What do we have tomorrow?
Tau.
What do you guys need to have ready?
Test.
What do you guys need to have ready for
Notes.
tomorrow? Oh,
true. And our
Ooh, notes, table of contents,
The best part is I still have to say
Homework?
yesterday's.
right? Numbers 1, 2, 3 through 6.
1 through
3, 4, 5, 6. Oh yeah,
Yeah.
I haven't graded any of them, huh? So 1 through 6. I'm gonna clutch both of them tomorrow. Have the day after. Makes life easier. But today we're going to review as much as we can in the time given.
You took a quiz on Boole and parametric, right?
Yeah.
Yeah.
Okay, so we're not being tested on it tomorrow?
No.
Cool.
Yes. Wait. No, we're not being tested on it, or no, we are being tested on
Sorry,
it?
we are not being tested on. Alright, forward. Technically, if you guys look in your book, and that's why I had your book open a second ago, but now I have to get it back there. There is a whole section of review exercises, key terms, etc. So I'm not giving you a practice test because it's limits and we're okay. But we are going to make sure that we're at least doing somewhat okay on what's going on. But we're going to do it in a fun way. So everybody come up. I want you to get a rag. I want you to get a pretend personal whiteboard and one of your expo markers that you brought in.
What happened to the whiteboards, Miss
Where
D?
does that go?
What happened to the whiteboards?
Oh, they're huge. I don't know if they need
You want the small ones back? I
Yeah.
don't know what you have.
Well,
them. I got them backwards. Wait, where are they?
They're in a little cup thing.
Oh, I put
Oh,
them
no.
down. You guys here? Actually, there's so few of you. Look at it. 1, 2, 3, 4.
I'll take a big one.
Seriously?
Yeah, I'll take a big one if they want the small ones.
Do you guys want these ones to give you more space?
no.
Yeah.
Okay. And then George will take a big one. Big one.
What do you have?
This is cool. We all get our own.
Wait, wait.
You guys ready?
All get our own.
I'm gonna hit Jack in the head while I'm going up for it.
You do not. Wait, what are you doing? No.
Nothing.
I disagree. I'm checking to make sure real quickly. The answers to the review exercises in the back, which they're
You know, should teacher digit.
there are answers to evens and odds to the review exercises in the back.
Seriously.
For us.
Here's what I want you guys to do. You ready? You do not have to write the problems.
I don't have a rag either. No, let's just go. We only have like 30 seconds.
Really?
I think. That's what I'm saying.
Chapel day. Where does it go?
Oh, okay.
So we're just doing one first, or what?
You don't have to write the problem, just give me answers. Let's see how many you can get done. Where does it go?
Okay.
You don't have to write the questions.
Okay, Miss D. Gosh.
Good.
Oh, you forget how to count.
We can see like we taking the limit. I got one done.
Isn't 3 not non-existent?
Yeah, 3's not existent.
Yeah, I think these.
No, wait, we gotta keep going? No.
Yeah, 3's not existent. Hold on, hold them up. Let me see. Let
I
them
got one.
One.
Look at me.
One.
I realized I did 3 instead of 2.
Ah, you
Yeah,
guys
I
look at
did
the
too.
same? Lame.
D and
You
E.
can go get it done. I don't have anything on the desk.
D and E,
Come on,
I got 2.
That's me and E.
Yeah,
I
you
got
know you're
two.
cheating.
I got 2 with D, I win.
Alright.
Yeah, that's me.
That's because you don't know how to read, Gerard. It doesn't make it another letter.
Alright, you ready for tomorrow?
But we didn't review.
Bye, guys.